Welcome to VR through an ID or instructional design lens. In this session, we will explore VR design from the perspective or lens of learning theory. Today's agenda is as follows. First, we're going to discuss three design-related learning theories: Behaviorism, Constructivism, and Experiential Learning. Next, we're going to demonstrate the relevance each of this theory has in terms of VR design. We're also going to explore practical examples of VR apps whose design is informed by these learning theories. And finally, we're going to speak about low-cost, low-threshold tools such as Adobe Captivate and Adobe Aero, which don't require coding knowledge and can empower instructional design practitioners to make their first foray into engaging VR design. So let's get started. So for each of these design-related learning theories, in addition to discussing each theory, I will also provide useful practical examples. So, the first learning theory we're going to discuss is behaviorism, and John Watson is known as the father of behaviorism. So, in the late 19th century is when this theory came into being, and there's several key ideas I want you to remember: repetition, stimulus, and response. So, repetition involves performing an action over and over and over again until it's second nature. Stimulus and response refers to the fact that people need to be directed. So a stimulus is something a learner wants, a reward, or fears, a punishment. And the individual will respond accordingly to this stimulus, and it will involve and provoke a change in behavior. So as far as practical examples, you might have a teacher who rewards a class with candy for good behavior at the end of the week. Now, if the class does not behave well, the teacher could certainly withhold this candy at the end of the week. Another example is a biology test. The teacher might say to the students, any student who gets 100% on a biology test that we're having will receive a sticker. So this will motivate the students to study harder. But if the teacher suddenly withholds the sticker, the student motivation will fall. From the perspective of VR design, the theory of behaviorism offers some important things to remember. First, simulated setting. Second, hands-on learning. Third, virtual environment that mirrors the real world. So, now I'm going to talk about a terrific example of a VR app whose design is closely related to behaviorism. This app is a fitness/game called Thrill of the Fight. So in the next slide, I'm going to show some video footage and talk a little bit more about how this particular app represents a prime example of behaviorism. So here you can see the example of repetition involving the speed bag. The fighter is practicing over and over and over to perfect his or her form on the speed bag. So as we can see, now we're in a fight situation, and we can see that the fighter is actually able to implement everything they've learned in training and is able to score a successful knockout. Constructivism is a learning theory that Jean Piaget came up with in the 20th century. This theory has to do with the fact that instead of simply absorbing information, that people construct knowledge. So think of it this way. People experience the world and build their own mental models of things, and also bring in new information into what they already know about something. So it's critical in terms of this theory for learners to think through problems, ask questions, investigate, and find solutions as well as answers. So a great practical example of constructivism in action would involve a traditional chemistry lecture. it may be difficult for students to comprehend stoichiometry, moles of molecules, and things of that nature. However, if the student were asked to pick a project involving a concept in chemistry like stoichiometry, for example, this would be a way for them to better understand this particular subject by constructing their own knowledge. And one other quick point that I wanted to mention about constructivism that's important is this particular theory involves the fact that the mental model already exists. So for example, students already have a mental model that exists involving chemistry. And when they engage in a chemistry project, they're able to add to their model and increase their knowledge. So I just wanted to make that point. Now, if we think about the theory of constructivism from the perspective of virtual reality design relevancy, there's a couple of key things to understand. One of them is pretending to be someone that you're not, or role play. Another would be learning that is highly cooperative and collaborative, and also learning that thinks outside the box. I know, you're probably thinking, what is a practical VR example for constructivism? It's a complicated theory. Well, it is a complicated theory, but fortunately, there is a VR example. Fantastic Contraption is a game that uses the theory of constructivism to reinforce aspects of physics. So think of it this way. Students are able to build on their existing mental model of physics in the virtual environment. So on the next slide, I'm going to actually talk through the game itself and how it lends itself to constructivism. So let's have a look. So the purpose of Fantastic Contraption is to get the pink ball into the pink goal. But you don't see students sitting in a classroom learning how to do this. They're actively constructing a fantastic contraption, and in doing so, building on their existing mental models of physics in the virtual environment. The next instructional theory we're going to discuss is experiential learning. And this was introduced by David Kolb in the 20th century. And it's an offshoot of constructivism. Experiential learning involves learning by doing. So for example, instead of reading a book about how to become a stand-up comic, in terms of an experiential learning method, one would actually go to a comedy club and perform at open mics. Another example involves myself. I am currently learning about the Python programming language. So I've watched a bunch of tutorials, and when I'm finished the tutorials, I will then work on the projects. So at the moment, I'm not terribly confident about my knowledge in Python because I really haven't created many Python programs at this point. I've mainly watched a lot of different tutorials. So from an experiential learning perspective, it's really about how do you get that model that exists from a constructivist perspective. Well, the way you get that model is through experiences, through actually writing, in this case, Python programs, instead of simply watching Python tutorials. So now we're going to explore how experiential learning is relevant from a VR design perspective. And there's really two aspects of it. First of all, it's about getting better at things, improving performance, and also learning through the senses. So, a tangible activity which represents experiential learning in a VR environment, is one that involves painting. So that's what I'm going to show you and talk a little bit about in the next slide. And remember, one option when you're trying to learn to paint would be to read a book about painting. But wouldn't it be much more effective if you actually learn how to be a painter by learning by doing? And that's what experiential learning is all about. So let's have a look at this next example. So instead of sitting in a classroom reading a book about painting, Painting VR allows us to actively engage in painting by mixing colors, choosing brushes, and really learning by doing. And that's why Painting VR is a terrific example of experiential learning. So one thing that you may have noticed in this presentation so far is that the examples that I've shown related to behaviorism, constructivism, and experiential learning, the VR examples that I've shown have been professional caliber examples. From Thrill of the Fight, to Fantastic Contraption, to Painting VR. However, in this last portion of the session, I'd like to speak about some low threshold virtual reality tools that instructional designers can use to create highly engaging virtual reality experiences without the need for coding knowledge. And two of these tools that I'm very familiar with and fond of are Adobe Captivate as well as Adobe Aero. So first, we're going to speak about Adobe Captivate in terms of its utility as a low threshold but powerful VR tool. Let's have a look. So as we see this screen for Captivate 2020, Captivate 2020 introduces virtual reality in the form of a VR template. In other words, within Captivate, it's possible to click VR template when you open the software. They have a repository of 360-degree video. So I selected one as part of their repository, in this case, a futuristic office. And then I also added several hotspots, which you can see, and added text to each of these hotspots. So as you can see, I attached the text to the first hotspot, open-mindedness. So this is a very low threshold but powerful way of building VR experiences in a low threshold, low cost manner. Now, as far as Captivate, some of you that work for universities may have Captivate as part of your license agreement with the company that makes it, TechSmith. But even if you don't, it's low cost enough, roughly $300 per person, that it makes sense in terms of a mechanism for creating low threshold VR experiences. So, the last tool that I'm going to speak about during this presentation is called Adobe Aero. Adobe Aero allows you to create animations involving triggers and actions instead of code. So what this means from a practical perspective for instructional designers is that similarly to Adobe Captivate, Adobe Aero is a tool that warrants adding to your toolkit. It is part of the Creative Cloud suite. It is currently in beta. But again, the ability to place avatars that are already part of the program, not like you have to create them, onto the virtual environment and animate these avatars via triggers and actions. That, from my perspective, as an instructional designer, is a real game changer. Because from the perspective of instructional designers, there are a lot of interesting apps out there and so forth. But how many of these apps are low threshold enough that it's actually possible to build something meaningful and significant without needing to use code? And so again, this is the real advantage of Adobe Aero, is it's sophisticated, but it doesn't need any coding. So, we've now reached the end of the session. So it's recap time. So, in this session, we learned about 3 design-related learning theories: Behaviorism, Constructivism, and Experiential Learning. We also learned about the way in which these theories are relevant from the perspective or lens of VR design. In addition, we looked not only at practical examples of the theories, but also practical examples of virtual reality apps that have been created with these theories in mind. And finally, we looked at low threshold virtual reality tools such as Adobe Captivate and Adobe Aero, which again serve to empower instructional designers by allowing them to add additional tools to their toolkit, which they can use without needing to become programmers, but using their instructional design knowledge of learning theory, to create highly engaging VR experiences. And so that, from my perspective, is the true benefit of many of these low threshold VR tools. One more thing I'd like to mention is, for those people that do have programming skills and are interested in VR development, whether they be instructional designers or others, 2 additional tools that you might want to look into are Blender as well as Unity, because both of these tools allow pretty heavy-duty development, but there is a pretty steep learning curve if you're not a programmer. So again, I have really enjoyed being part of GatherVerse and really enjoyed talking with you about learning theory and its connection with virtual reality design. Again, I hope you enjoyed this session, and I thank you so much for your attention, and please let me know if you have any questions. Thank you so much.